Section 2.2 is infinite limits and limits at infinity. Again, you should check out the notes if you're my student that I provided you on Canvas because it tells you definitions and theorems. We're just going to touch lightly on those definitions and theorems as we do some examples. The first example we have, describe the end behavior of each polynomial. Well, we reviewed this, so we should remember how to find the end behavior. So let's start by doing that. Okay, so in the first one, remember you need to look at your degree. And our degree is 2. And we need to look at the leading coefficient. Remember, I like to put LC for the leading coefficient. So my leading coefficient is 4. So my degree was even. That means it's going to be the same on both sides. And my leading coefficient was positive. So that means since they're the same on both sides, they're both going to go up. Okay, so the end behavior is up on both sides. Well, what does that mean if we want to write out some limits? Okay, well, we're going to figure out the limit as x goes to negative infinity of our function. And we're going to figure out what the limit is as x goes to positive infinity of f of x. Okay, well, think about your x-axis. If x is going to negative infinity, that's talking about the left side. If x is going to positive infinity, that's talking about the right side. Okay, so x going to negative infinity is whatever's on your left side, and x going to positive infinity is whatever's on your right side. Okay, well then they want what happened on the left side here. Well, my function is going up, so it's going to positive infinity. So that's my answer, positive infinity. What's happening on the right? Well, again, it's going up, so it's going to positive infinity. Let's take a look at another example. Okay, so in this one, our degree is 3. And our leading coefficient is negative 5. So my degree this time was odd. Remember, that means it's going to be opposite directions. One side's going to go up and one side's going to go down. And then my leading coefficient was negative. Remember, the leading coefficient is going to tell you the right side. So the right side is going to go down. And since it was an odd degree, they're opposite, so the other side, or the left side, is going to go up. Okay, well, again, x going to negative infinity is whatever's happening on the left side, and x going to positive infinity is whatever's happening on the right side. So if I write out my limits, I'll have the limit as x goes to negative infinity of f of x equals, well, the left side was going up, so it's going to positive infinity. And then I've got the limit as x is going to positive infinity of f of x. Well, that's whatever's on the right side. So on the right side, it was going down, so I'm going to put negative infinity. Okay, let's take a look at example 2. In example 2, it says find all horizontal asymptotes of each function. Again, we reviewed horizontal asymptotes, so hopefully you remember the rules. We'll remind ourselves while we're doing these examples. So in the first one, I have 6x to the 4th plus 2x minus 1 all over 4x to the 4th plus 2x minus 7. Well, remember, you're going to look at the degree of the numerator and the degree of the denominator. So the degree of the numerator is 4, and the degree of the numerator is 4. So you have the same degree on the top and the bottom. Whenever it's the same, remember you use your leading coefficients to tell you your horizontal asymptote. So 6/4 is your horizontal asymptote, or more specifically, y equals 6/4. And of course we can reduce that to 3/2. So y equals 3/2 is your horizontal asymptote, but again, this also tells you some limits. It tells you the limit as x goes to negative infinity of f of x, and it tells you the limit as x goes to positive infinity of f of x. And they're both going to be the same. So they're both equal to 3/2. Okay, part B. They give me f of x equals 2x squared plus 9 over 8x cubed plus 1. Well, again, look at the degrees. The degree on top is 2. The degree on bottom is 3. The degree on top is smaller, so that means y equals 0 is the horizontal asymptote. And that tells you your limits again. So you've got the limit as x goes to negative infinity of f of x, and the limit as x goes to positive infinity of f of x. And they're both going to be 0. Okay, so your horizontal asymptotes are helping you find your limits. And then part C, f of x equals 2x to the 5th plus 5x plus 1 all over 3x cubed plus 2. Well, the degree on top is 5, the degree on bottom is 3. Remember, when the degree on top is higher, there are no horizontal asymptotes. But you can find a limit. And what you're going to do is you're going to actually use your end behavior rules. So you're going to use the leading term from both the top and the bottom. Go ahead and write them down. So I've got 2x to the 5th over 3x cubed. Of course, when you're taking the leading term, what I mean is you're taking the term with the highest exponent from the top, and you're taking the term with the highest exponent from the bottom. So if they're out of order, make sure that you're using the term with the highest exponent. Okay, so then simplify it. Well, 2/3 doesn't simplify any further, but x to the 5th divided by x cubed, well, remember, you can just subtract your exponents here, and we get x squared. And then use your your end behavior rules. So my degree here is 2. My leading coefficient is 2/3. The degree is even. The leading coefficient is positive. So that means they're both going to be the same, and this tells you they're both up then. Okay, so in this one, the limit as x goes to negative infinity of f of x, and the limit as x goes to positive infinity of f of x are the same answer because both sides were going up. They're both positive infinity. But you might have had an odd degree, and then you'd have one side going up and one side going down, so you'd have to be careful to figure out what is the left-hand side doing, what is the right-hand side doing. Okay, but they're very similar to your first example. So try out the homework, make sure you read those notes, and let me know if you have any questions.